All right, this video, if you are in trigonometry, is in 4.4, and if you are in pre-cal, it is in 3.4. We are going to be working with equations that involve exponential functions and logarithmic functions, okay? So a pro and con about these questions is that there are several ways to solve them. I'm going to go over a few of them. One of them is to convert between exponential and log, so change the format. And then you want to end up with one term on each side in order to do this, okay? So this one will only work when there's one term on each side. Remember when we talked a few lessons ago about drop the base, change the place in the x and the y? That's what this is, okay? Next is to express each side as the power of the same base. So if you can get both sides to have the exact same base, you can ignore those bases and then just work with the exponents, okay? Now, the last one that I'm going to bring up is my personal favorite. It might take a little longer sometimes, but it is the one that is guaranteed to work just about every time, okay? Which is to apply a log or an ln to both sides. This is useful because remember the rule that we have with manipulating logs that we can move the exponent to the coefficient and back and forth? That's going to help us out a lot. So you're going to isolate the exponential term. You're going to put the log or ln on both sides and then move the exponent of the log to the coefficient. Okay? So as I start solving these problems, I'm going to solve them in maybe like 2 different ways. So you guys get exposed to them, and then you can go picking the one you like and doing whichever one you like, okay? So if your answer looks a little different than the answer key in the back of the book, don't be afraid. Have your calculator out, and as long as your decimals, when you plug in the answer in the back of the book and the answer you get, match up, then you're good. Does that make sense? All right. So let's start looking at this first one, okay? So for this first one, it is currently in exponential form. The first method I'm going to show you is by converting to logarithmic form. Now, once you have x by itself, you are 100% done with the question, okay? I don't care how messy it is. So if I'm converting to log, I'm going to drop the base and switch the place of the x and the y. Okay? Now, this is a super easy question because in one step, I got x by itself. Okay? Option number 2, if you couldn't catch to use the conversion rule, is the one that works every time, which is to apply the log to both sides. Now, every time I say a rule for log, it applies the exact same way for ln. Remember, ln is just a type of log. So as long as you stay consistent, like don't use log on one side and ln on the other, that will give you a wrong answer. So here, if I put a log on both sides, now I have the freedom to move this x out of the exponent. And I can say x times log of 3 equals log of 21. And now what would I do to get that x by itself? Divide log of 3. And now I have x by itself, so I am done. And if you remember the rules from a few lessons ago, we talked about the change of base rule. Compare your two answers. We said that the change of base rule says that we can rewrite this as log of the bigger number, 21, divided by log of 3. And that's one way that you can see that your answers are indeed the same exact thing. So let's look at this next one over here. I'm going to start off by showing you the example of getting the same base, okay? Because 64 and 32 are even numbers, that for me is a flag to let me know that they probably can be rewritten with a base of 2. Like 2 raised to something could give me 64, and 2 raised to something could give me 32. So if you're willing to play a little bit in your calculator and test out those bases, you'd come up with that 64 can be rewritten as 2 raised to the 6, and 32 could be rewritten as 2 raised to the 5th. Okay? Now, who remembers the rule of an exponent raised to an exponent? You multiply them. Good. So 6 times 3x would give me 18x. And then 5 times 2 plus x, be careful here, what would that give me? 10 plus 5x. Good. Make sure you distribute. Do you see how I have the same base on both sides? I can ignore the 2's. And now I can just say 18x equals 10 plus 5x. And now some simple algebra. Okay. If you don't feel confident in catching when you can change the base, this is a shorter version than what I'm going to show you next. But if you don't feel confident in catching that you can change the base, you can, just like in the last question, apply the logs. Now, I told you that applying the logs works the same as applying ln. So just for the sake of exposing you to both, I'm going to show you ln on this one. Okay? So here's option number 2. I'm going to rewrite the question really quick. I am allowed to apply an ln to both sides. Okay? When I do that, it allows me to move the exponent to the front. So now I can write 3x times ln of 64 equals, if you have more than one term in that exponent, write it in parentheses, 2 plus x times ln of 32. Because this ln of 32 now needs to get multiplied to the 2 and to the x. Okay? So this guy right here needs to get multiplied to both. So if I clean that up really quick, it'll say 3x ln of 64 equals 2 ln of 32 plus x ln of 32. So now, just like how you were taught in Algebra 1 that when you wanted to solve for a variable, you got anything that had that variable over to one side and anything that did not have the variable to the other, we're going to do the same thing here. So out of the 3 terms, 2 of them have an x in it. I want these 2 terms to end up on the same side, and this third one that doesn't have an x, I'll leave this one on the right side. So I'm going to say 3x ln of 64. I'm going to subtract this one over, minus x ln of 32, and then equals, I'm going to leave this one over here on the right side. Now that my 2 terms on the left have an x in common, what can I do? I can factor it out and pull that x out, okay? So if I take that x out, I'm left with 3 ln of 64 minus ln of 32 equals 2 ln of 32. And my last step to get that x by itself? Divide. So I'm going to have 2 ln of 32 divided by 3 ln of 64 minus ln of 32. Okay. Now let's take a moment and plug this into our calculator to confirm that both methods do give me the exact same answer. So when you plug that last answer that you just got into your calculator, you should get 10 over 13. If you got some weird decimal, remember that you have the option to press the math button, and number 1 says frac for fraction, that you can convert it. Okay? But you just had your proof that this long answer is identical to that 10 over 13. Okay? So looking at this next question, if I wanted to try and get the same base, it'd be a little hard here because 3 and 7 are odd numbers and they're prime. So I can't really bring them down anymore to say 2 raised to something or 3 raised to something. So here I'm kind of forced to use the ln or the log rule. I personally like using ln because it's shorter to write. But again, it doesn't make a difference. So apply the ln to both sides to move that exponent to the front. Okay, now on both sides I have 2 terms, so on both sides I'm going to have to distribute. Okay, now our goal is to get the ones with the x's on one side and the ones without the x's on the opposite side. Now, from here on, depending on which side you move your x's to, our signs at the end might look a little different, but we will still have the same final answer, okay? So I personally like moving my variables to the left, but that again will not change your final answer. So I subtracted this 3x ln of 7 to the left, and now I'm going to subtract this 2 ln of 3 over to the right. Okay. Now on my left side, I see that I have an x in common, so I can factor it out. And then my last step to get that x by itself, divide. If your terms land in a different order, it is okay as long as our signs are identical or all completely opposite. One more time. Your terms can be in a different order horizontally, like next to each other. It can't be like one should be in the denominator and when it's on yours it's on the numerator, okay? They can be in a different order, meaning these two can trade places or these two can trade places, as long as the signs are exactly the same as mine or completely opposite. So if you had positive, positive, negative, positive, this would still be correct, okay? So for this next one, it already has a log in the way. So hopefully you can catch that there's a nice little base here that you can drop and convert this over to exponential. So you switch the place of the 4 and the x plus 5. Okay? Even if you just subtract the 5 over and say 2 to the 4th minus 5 equals x, your x is by itself and you are technically done. Okay? But for the sake of being neat, what is 2 to the 4th power? 16. Right? And then minus 5. X is 11. All right, so now we're going to start to see some questions that already have a log in the way. Okay? So when I look at this first question here, I have some options. Okay? Let's look at our options first. I can divide this 4 over to the 12, or I also have the rule where I can move this 4 up as an exponent. Which one do you guys want to do? Divide? Okay, so if I divide by 4, oops, I have ln of 3x equals 3. What do you want to do next? Drop the base. What's the base there? Nice. My base is e. So I could say e raised to the 3rd power equals 3x. And now, just divide the 3 to get x by itself. X equals e to the 3rd over 3. Okay? Another option you could have done on this step, let's say, let me use a red pen. From here, let's say here's my OR. You are allowed to apply an E as a base to both sides. Okay? So you know how I was applying a log to both sides? I'm allowed to apply a base of E to both sides. What happens with ln's and e's? It equals 1. They cancel out. So now I have 1 times 3x, which is just 3x, equals e to the third. And now I'm right back at this step. Just all I would have left is to divide that 3. Okay? Different options. So now looking at letter F, we have options again. Whenever I see more than one ln or log on one side, I want to try and combine them with the rules that I have from the previous lesson. So some options are, and I'm going to expose you to them and then let you pick which one you want to do. I have the rule that 2 ln's being subtracted can turn into division. Okay? Now, if I choose that as my option, this becomes ln of 1 over 3x minus 2, and now I have a fraction in the way. Okay? Option number 2, I can add this to the other side, and now I'd have 2 ln's on the right side being separated by addition, which turns into multiplication. So now I wouldn't have fractions that way. Another option that I have, who remembers off the top of their head what ln of 1 is? ln of 1 is 0, okay? So if you remember that, that is another option, okay? I'm going to, for the sake of the notes, use the method assuming you probably didn't remember ln of 1 is 0, which I hope you start to burn that in your brain, especially those of you who are thinking of calculus, okay? And I don't know about you, but if I can avoid a fraction, I will. So I'm going to add this negative ln over to the other side and say ln of 1 equals ln of x plus ln of 3x minus 2. Okay? Now, on that right side, I have the rule that 2 separate logs separated by addition can become a single log, and then I multiply the insides. Okay? Now, remember how I can add a log to both sides? Okay? It'll work the same way, and even like when I had a single base on each side, I can cancel out if I have a single ln or log on both sides. Okay? You can remember that as the rule. The reasoning behind why I'm allowed to do that, remember how here I put a base of e on both sides? I can do the same thing here. I could put a base of e on both sides, and this cancels. Okay? And now I have 1 equals x times 3x, 3x squared, and then x times a negative 2 is negative 2x. Now I'm just working with a polynomial. How many answers am I going to have to this polynomial? 2. My highest exponent is 2. So I'm going to move that 1 to the other side. So I'm subtracting the 1 to the right side. And now I'm working on getting 2 binomials. Okay? 2 numbers that multiply to give me 3x squared. A 1x and a 3x. Okay? 2 numbers that multiply to give me 1. 1 and 1. Now, remember, when I FOIL this inner, this 1 times 3x, and this outer 1 times x needs to combine to give me a negative 2. Does the bigger or smaller numbers have to have the negative if my final answer is negative? The bigger numbers. Who's bigger, the 1 and the 3 or the 1 and the x? So the 1 and the 3 need to have the negative. And now I could say x is positive 1. And here if I subtract the 1 over and then divide by 3, I get my next answer. So again, I keep talking about those three rules that we talked about in 3.3. So earlier, we were putting logs so we can move things out of the exponent into the coefficient. That is beneficial when my x is stuck in the exponent. Okay? That's when I want to take things out of the exponent. But in this case, I want to try and get rid of these two logs because I have one on each side. But I have these coefficients stuck in the way. What do you think I could do with those coefficients? I'm going to move those coefficients, up into the exponent. Once those coefficients are gone, now I have log of x cubed equals log of 27 to the negative first. So remember on the last question how we applied a base of e to both sides to get rid of the ln's? What do you think I'm going to apply here as a base? 10. So if I apply a base of 10, it's going to cancel the logs. Right. So then 1 times x cubed is just x cubed equals, what's an easier way of saying 27 to the negative first? 1 over 27. Okay? And now last step to get x by itself is to cube root, that's right side, and x is by itself, so I am done. All right, so let's look at this question on the right, and this is a similar issue that comes up in algebra. I have a lot of students that just want to subtract this log of of x minus 3 over to the left and cancel them out. In algebra, if you ever completely cancel out a variable, you will miss one of the options. So for example, you see up here how we got 2 answers? This looks like one of those that we're going to get 2 answers, but if you completely cancel these 2 out, you are only going to get 1 out of the 2 answers. Does that make sense? So let's combine these 2 logs on the right here. Remember, 2 separate logs separated by addition. I would multiply the insides. So what is x times x plus 3? X squared, good, plus 3x. And then on this side, I have log of x plus 3. How do I eliminate those logs? A base of 10. Okay? So now I have x plus 3 equals x squared plus 3x. I'm down to a polynomial. Get everything on the same side. And of course, our favorite part, factoring. Two things that multiply to give me x squared. X and x. 2 numbers that multiply to give me a 3. 1 and 3. And if I need my middle term to be positive, who needs to be positive? The 3, the bigger number. Okay, the bigger number carries the weight. So now I get x equals 1 and negative 3. So just for those of you in case you did make the mistake, if you would have canceled out these logs of x plus 3, I believe the only answer you do get is the 1, and you would have missed out on the negative 3. Okay? So now the big question comes in as to why in the world do we need to learn to solve these functions with logs? Okay? We talked about money earlier on, about learning how money grows compounded with interest. Okay? So what exists in the exponent of that equation? N and T. Let's write that equation really quick. We have that the total amount equals P, the principal, the initial amount, of times 1 plus the rate over N raised to T times N. How do we get that T? If what I want to solve for is how long will it take my money to grow, how do I get that T out of the exponent? How can I move it to the front? With logs and ln's. Okay? All right, so let's start analyzing the question. It says, how long will it take? That statement, how long will it take, is what lets you know that you are solving for time. Okay? How long will it take 3,000 to grow into 30,000? What is 3,000? My P, it's the initial amount that I put in. And what is 30,000? A, the total amount of money that I want. At a 5% interest rate, what is that? And how will I represent R? Good. 0.05 as a decimal. And they want it to compound semi-annually. What is 2? N is 2. Okay? So plug in what you know. Okay? So once I fill out that equation, on my right side, I have 3,000 times a base that is still stuck with an exponent of t. So what I want to start doing to get t by itself is get this base by itself. So I'm going to divide the 3,000 over. What is 30,000 divided by 3,000? 10. So I could say 10 equals 1 plus 0.05 over 2 raised to 2t. Okay? Now again, I am allowed to use ln or log. Okay? Anytime you see an e, ln is obviously easier because ln's and e's cancel out. And anytime you see a 10, log is easier because logs and 10 cancel out. On purpose, I'm not going to use log here because the chances that you're going to get 10 on your homework quiz or any other questions is rare. So I'm going to use ln just so you see how it would work for any other problem where that doesn't cancel out. Okay? So my next step will be to apply an ln to both sides. The purpose of this is to now move this 2t out of there. Okay? So I have ln of 10 equals 2 times t times ln of this whole parentheses. Now, some of you might be eager to clean this inside of this parentheses. You're like, that's easy. I could do that. I encourage my students, especially those going into calculus and AP, to not waste time doing that. Because as long as you get t by itself, you have finished the problem. Okay? And if it's a calculator question, you can just plug it all in at once at the end. Okay? So now to get t by itself, I want to divide everything else over. So I'd have ln of 10 over, I'm dividing the 2, and I'm dividing this ln of 1 plus 0.05 over 2. Okay? And because this is a word problem and I truly want to know how long it's going to take my money to go from 3,000 to 30,000, let's take a minute and put that in my calculator. All right, so your calculator should look something like this. You should have gotten 46.624 years, okay? So you can't get that money on the 46th year. You have to wait to the 47th year. But you let $3,000 sit. You didn't touch it for 47 years, and it turned into 30,000.